Okay, hello everyone. In this video, we'll be showing how to do some common ratios without using a calculator. And of course, I do have my calculator here, but that's not because we'll need it for to prove certain points. But essentially, when this video is finished, you should be able to do certain three equations without using a calculator. So here we go. First of all, the sine, cos, and tan functions are all wave functions, meaning they repeat in a wave cycle. So the values for sine 45 or sine 60, you'll see it repeating for another sine higher up as it just keeps repeating and going over and over again. So firstly, let's look at these. These are the most common sine, cos, and tans that you'll ever see. So let's go through them. Sine 45 is equal to root 2 over 2. Sine 30 is equal to a half. And sine 60 is equal to root 3 over 2. Cos 45 is equal to root 2 over 2. Cos 30 is equal to root 3 over 2. And cos 60 is equal to a half. Tan 30 is equal to root 3 over 3. Tan 60 is equal to root 3. And tan 45 is equal to 1. Now, like I said, they are wave functions which go in a cycle, and therefore they continuously repeat themselves. Here we have what's supposed to be kind of a graph, and we can, looking at here, we can start from 0, and we going anti-clockwise. We first go to 90 degrees, then 180, then 270, and then back to 0 degrees. So basically, if we have an angle within here, there is an angle in this part that also has the same value, and an angle in this part that has the same value, angle in this part has the same value when you have a certain function, right? But the only thing is that depending on where it is, it may have a negative or positive value. These four parts are called quadrants. In the first quadrant here, sine, cos, and tan are all positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. And in the fourth quadrant, only cos is positive. So let's say we have an angle theta, and let's let theta equal 30 degrees. Sine of 30 is equal to a half. Okay, so looking at this, it says that in the second quadrant, the equivalent of the first quadrant version is 180 minus theta. Since theta is equal to 30 degrees, then that will be 180 minus 30, which is 150. If we put sine of 150 into the calculator, we see that sine of 150 degrees is also equal to a half. If we do the same for the third quadrant, according to the equivalency, it's 180 plus theta. So 180 plus 30, which is 210. Plug it into the calculator. We'll see that we get negative a half, because as you see, only tan is positive, therefore the sine function must be a negative. So if we know the angle within the 0 to 90 degrees, if we know the value of its sine, cos, or tan, then we know what is called the base angle, and we can go ahead and use either 180 minus theta, 180 plus theta, or 360 minus theta for the fourth quadrant to find what it will be what the value will be in all those quadrants, and if it will be negative or positive. To remember this, we use the acronym CAST, C-A-S-T. So here they're all positive. Here sine is positive, tan is positive, and cos is positive. Let's try the angle 60 degrees. Put on a theta here and let theta equal 60 degrees. As we see here, cos 60 is equal to a half. Now let's find the second quadrant equivalent of that, which should be 180 minus 60, and that should be 120. If we say cos of 120, then we get negative a half, and of course that proves that proves to be true because only sign is positive here. So of course cos 120 would be equivalent to cos 60, only that it would be negative instead of positive. The only one of these that would end up being positive again would be cos of 360 minus 60, which is 300, and here we can show that cos 300 does indeed equal a half. And of course you can try that with tan as well. Now, knowing these common ones, we can do a thing called compound angles and double angles. First, let's take a look at the formulas. So, sine A plus or minus B is equal to sine A cos B plus or minus cos A sine B. Cos A plus or minus B is equal to cos A cos B minus or plus sine A sine B. Tan A plus or minus B is equal to tan A plus or minus tan B, all divided by 1 plus tan A tan B. Now, what this basically means that if you have if you have a very large angle, you can split it up into two better known angles and use this formula to solve for it. Let's try with 255. Let's say we have to sine 255. This can be split into, say, sine 210 plus 45, with 210 being A and 45 being B. So we can rewrite this as sine 210 cos 45 plus cos 210 sine 45. Now of course we know that cos and sine 45 are both root over 2, but how do we know what sine 210 and cos 210 is? Now firstly, the fact that it is between 180 and 270 tells you it's in the second, it's in the third quadrant. Actually it's in the third quadrant. Between 180 and 270 it's in the third quadrant. And as you know, the third quadrant is represented by 180 plus the base angle theta is equal to say 210. So 180 plus the base angle is equal to the angle that we have within that quadrant. So we can rearrange this and say theta equals 210 minus 180, and that gives us a base angle of theta equals 30 degrees. So since we know the base angle and we know what is sine of the base angle and what is cos of the base angle, we can figure out what is cos of 210 and what is sine of 210. Now sine of 30 degrees is a half, and therefore sine of 210 would be a half of some kind. Since it's in the third quadrant where sine is negative, then sine 210 would end up being negative a half. And again, it's in the third quadrant, so that's where cos is also negative. Therefore cos 210 would be negative root 3 over 2. So as you remember, cos 30 is root 3 over 2, not a half. Cos 30 is root 3 over 2, therefore cos 210 is negative root 3 over 2. So if we plug all of these into here, and so for those, we would get sine 210, which is negative a half, times cos 45, which we know to be root 2 over 2, plus cos 210, which we know is negative root 3 over 2, times sine 45, which is also root 2 over 2, and we can go ahead and write this as negative root 2 over 4 plus negative root 6 over 4. Since it has the same denominator, we can just go ahead and add these normally. And so we have negative root 2 minus root 6 all over 4, and that is how you get sine 255. Let's try again with another angle, this time cos. Let's try cos 75 degrees. Now this one is pretty easy. Here we can see that 75 can be split up into 30 plus 45 degrees. And as we know, the double angle formula is cos A cos B, and then this here will be a minus, because around here it says cos A plus or minus B, and then here we have minus or plus. So when there's a plus here, this becomes minus, and there's a minus here, this becomes a plus. So going back to this, minus sine A sine B, with A being 30 degrees and B being 45. Now we can just plug those in. So cos 30 cos 45 minus sine 30 times sine 45. When we're in common angles, we can then put, we're just writing the equivalent. So we know our cos 30 is root 3 over 2, and times cos 45, which is root 2 over 2, minus sine 30, which is a half, and sine 45, which is root 2 over 2, and you can just multiply these across, and we get root 6 over 4 minus root 2 over 4. Since we have the same denominator, we can just subtract the numerators, and we get root 6 minus root 2 all over 4. There we have it, and that's how you can simplify angles by making them into a compound angle. Let's go ahead to double angles. Now here are double angle formulas. First thing, let's make one thing clear. Sine 2 theta is not equal to sine theta times 2. There are specific angles for doing them, and here they are. Sine 2 theta is equal to 2 sine theta cos theta, and the cos 2 theta is equal to cos squared theta minus sine squared theta. Tan 2 theta is equal to 2 tan theta minus 1 tan squared theta. Let's try how sine 2 theta when theta is equal to 60 degrees. So, say theta equals to the sine of 2 times 60 degrees is equal to 2 sine 60 times cos 60. And we know what those are, so we can say 2 times root 3 over 2 times a half. 2 times 2, and we end up with root 3 over 2. And we can prove this because we know that 2 times 60 is 120. So if we try to solve for sine 120, we know that this is in the second quadrant because it's between 90 and 180. And according to the rules we laid out earlier, we can find this base angle by saying 180 minus theta is equal to 120 degrees. Here you can see that negative theta is equal to 120 minus 180. Therefore negative theta is equal to negative 60 and theta is equal to 60. And as we know, sine is positive in that quadrant, and sine of 60 is root over 2. Therefore sine of 120 must also be root over 2. And that's how double angles work. Thank you for watching.